Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. In this lesson, we will start with the topic on gums and stabilizers, or sometimes we use the term hydrocolloids. Hydrocolloids is actually actual material or the ingredient, but hydrocolloids is a group. It has many functional properties, and some of the properties is actually the ability of the hydrocolloid to form a viscous solution, to give viscosity and to provide viscosity, so as a viscosifying agent. And another main function of hydrocolloids is its ability to form a gel. But not all hydrocolloids can form gel, and not hydrocolloids can almost all hydrocolloids can give high viscosity even at low solid concentration, but only some hydrocolloids can form a gel, and some can form a gel on heating. So when we heat up, it can form a gel. For example, egg white, when you heat up the protein with the nature and can form a gel. Another example is the carbohydrate derivative. For example, methyl cellulose. So when we heat up the methyl cellulose solution, it can form a gel. But most other hydrocolloids can form gel only on cooling. For example, agar or gelatin. When we have to heat up, dissolve the hydrocolloids, then we cool it down and can form a gel. So that's some of the properties of hydrocolloids. So to learn more about this topic, I want to refer you to the website. Let's check on this website. This is the website on the science of food ingredients. So on this website, you can see there are many topics on this website, but I just want to focus on gums and stabilizers here. This is actually a collection of articles, videos that you can use, you can read on your own for your self-study, and I have selected only the best content for you. Okay, so feel free to explore and study on your own and make notes, because there's so much information here. So let's see. Hydrocolloids or gums are substances consisting of hydrophilic long-chain high molecular weight molecules. So it is actually a polymer, a big molecules, and mainly they are polysaccharides, except for things like gelatin. Gelatin is also hydrocolloids because it can bind a lot of water. It's very hydrophilic, but gelatin is one of few examples of hydrocolloids from animal source, from mammalian, from cow, from pig bone and skin. But most of the other types of hydrocolloids that we discuss in this topic are actually derived from plant and from different parts of the plant. Some are from fruits, some are from tubers, some are from seaweeds, for example alginate, agar, carrageenan. Okay, and one of the common properties of hydrocolloids at low concentration, let's say around 1% solid concentration, we add water, it can form very highly viscous solution. So this is very good because we can use this as a viscosity and to provide viscosity. And because hydrocolloid can give viscosity, we can use hydrocolloids as a viscosifying agent or as a stabilizer. So when we have let's say an emulsion for example in yogurt drink or yogurt beverage, this is an example of emulsion. But emulsion usually has a low stability. Okay, so therefore, to increase the shelf life and the stability, especially during storage, we can add hydrocolloids as a stabilizer, so you can kind of hold the emulsion and for a long time without separating. So that's why we we describe hydrocolloids as gums because it's very sticky when in the form of solution, so it's gummy or sticky. Also as a stabilizer because it can provide viscosity and stabilize the food emulsion. That's the reason we call it stabilizers. But the functions of food hydrocolloids are not limited only to as a viscosifying agent or as a gelling agent. It can also form a gel. It can also use as a stabilizer. But there are many other functions of hydrocolloids which we will learn more in this topic. Okay, so as you can see here, it can form highly viscous suspension or solution with low dry substance content, and around 1% it can give very high concentration, very high viscosity, for example xanthan gum. Yeah? In addition to their primary purpose of thickening, so it's a thickening agent or gelling agent, as you can see in the picture here, hydrocolloids often exhibit related secondary function, okay, such as emulsifying. Not all hydrocolloids can provide emulsifying property. There are only a few examples. For example, propylene glycol alginate. Arabic gum, yes, they can provide some emulsifying or emulsifying property, but the rest of hydrocolloids cannot function as an emulsifier. Hydrocolloids can be used as a whipping agent, suspending agent, and also in the process of encapsulation. For example, in flavor encapsulation to retain the flavor, we can use hydrocolloids as encapsulating agent to provide the protective layer and prevent the flavor to escape, the volatile flavor from escaping. So they are generally polysaccharides, but gelatin, which is a protein, is included in the category of hydrocolloids because they provide the same functionality. For example, provide viscosity. They can form a gel, and therefore we discuss gelatin as in the same group of food hydrocolloids. Okay, in the class I have shown you one website from this is actually commercial supplier of hydrocolloids, very well known and very established. TIC gums, TIC, TIC gums. So you can go to this website and they have a lot of good resources. And one of the resources that I want you to download is this table. So this table, which lists all the food gums and the properties. So this is a very good reference for you. And I have downloaded this table, and this is how it looks like. Common gums. So what we have in this table, each type of hydrocolloid contains multiple grades within their product categories and may be processed under various conditions. So as you can see here, on this column we have hydrocolloid name, and we have the common name or the common label declaration. What is the source of these hydrocolloids? And more importantly is the properties, the functionalities, the solubility, whether some can be solubilized in cold water or at room temperature. Some need to be, only can solubilize at elevated temperature. So you need to know, the different properties as well as the pH tolerance. Some hydrocolloids, for example, xanthan gum has a wide pH tolerance, meaning that it can retain the viscosity. It won't break down. It won't lose the viscosity at low pH, even at a higher pH. But some gums are not very stable at extreme pH, acidic or alkaline pH. Okay, so there you go. To start with, for this topic, I want you to read the resources that I have given you, and this table would be a very useful and helpful table for you to get the overall picture of the topic on gum and stabilizers. So you have to use all the resources that I provide to you, and you don't have to read everything, but selected resources, selected articles and video, and make your own notes. And when we have a class, I will give you some activities to go through to make sure that you basically understand everything, and you can apply what you have learned in the actual application of food hydrocolloids in formulating new products. Okay, so that's all for now in this lesson. I will see you in another lesson. Okay, bye bye.